Question. We are up to question number 4. Steel bars, each of length. Oh, let me go to the side. Steel bars, each of length 3 meters at 28 degrees Celsius, are to be used for constructing a railway. A railway line or a rail line, it's the same thing, right? If the linear expansivity of steel is this, what is the safety gap that must be left between successive bars if the highest recorded temperature expected is 40 degrees centigrade? All right? Look at it. Safety bar. It's talking about something here. Safety bar. That means this safety gap is the new length. The gap between the initial length and the next bar. All right? That is the new length. So we must find the difference. The difference is the safety gap that we are asked to calculate in this question. Right? If you understand that, you solve this. It's still the same thing. Nothing has changed. Solution remains what we already know, which is bars, each of length. Each of them has this length. That means L1 is equal to 3.0 meters. Okay? All right? But you can see we don't have L2. At this, the initial temperature is 28 degrees centigrade. So we have theta 1 is just 28 degrees centigrade, right? To be used for constructing a rail line, if the linear expansivity is alpha 1.0 times 10 raised to the power minus 5 per degree centigrade, right? Per degree centigrade or Celsius. All right. What is the safety gap? We are talking about the safety gap. We must find L2, which is unknown. Okay? After finding L2, we now find expansion, which is E equals to L2 minus L1. So take note of this. It's very, very important. Once we get this, E represents the safety gap we're looking for. Expansion that occurred represents the safety gap we're looking for. This is safety gap, all right, that we're looking for. So let's go. Let's go to work now. What we're looking for L2. It means L2 minus L1 is equal to, from our formula, I think the first thing to do is to state the formula, and then from there we make L2 minus L1 the subject. Alpha is equal to L2 minus L1 all over L1 bracket open theta 2 minus theta 1 all bracket close. Interesting. So L2, therefore L2 minus L1 is equal to alpha L1 bracket open theta 2 minus theta 1 bracket all closed. Good. If that is the case, we have something to do here. We have something to do here. And if we have that, that is very, very interesting. So whatever we have, we substitute. L2 minus L1 is equal to, what do we have as our linear expansivity is 1.0 times 10 raised to the power minus 5. And what do we have as initial length? Initial length is 3. Simple. Okay? Simple. Then what do we have? A change in temperature. Change in temperature. Theta 1. Theta 1. Oh, theta 2. Theta 2. So let's just quickly write that. Theta 2 is equal to 40 degrees centigrade. Alright? So theta 1 is 28, and then this theta 2 is 40. Yes. So what do we have there? If we do that, we then have 40 minus 28. and then close, right? So let's see, 40 minus 28, what do we have? Of course, I think it should be 12. So we have L2 minus L1 is equal to all that. Let's find out all this. Okay, if we find out all that, so what we're going to have is 1.0 times 10 raised to the power minus 5 times 3 times 14 minus this. We get 12. Right? That should be 12. Bracket close at this point. We now make L2, right? L2, whatever we have here. Okay? We now find that. After finding that, look at this. If we find that we have L2 minus L1, let's find all this and put it here. Okay? When we do that, find L2, you know what to do to find L2. At the end, apply extension or expansion equals to L2 minus L1. Whatever it gives is the safety gap according to this. Is the safety gap. Once we find the safety gap, once we finish with this and have a figure here, then we make L2 the subject at this point, after which find the expansion, which is L2 minus L1. Whatever remains is the safety gap that must be left between successive bars should we record the highest temperature of 40 degrees Celsius. That's it. It's solved. I want you to do the remaining work, okay? And then put it in the comment section. See you there. I need some thumbs up, subscribe, share with your students, or share with your fellow students. Don't forget, I want to read your comments. I want to read a comment about this. See you next time.